Let the complex numbers alpha and 1 by alpha conjugate lies on these two circles respectively. That means alpha is on the first circle, z minus mod z naught square equals to 4, and 1 by alpha conjugate is on second circle. Also, you can see that these two are concentric circle because for both of them the center is at point z naught, right? So then, and it is given that z naught is 1 plus iota. Then the question is, what is the value of 100 alpha square? 100 into mod alpha square, right? Modulus of alpha square. Now, there are different methods of solving this problem. One approach will be that point alpha lies on first circle. So that will give you one equation in alpha, and z naught is already given. And similarly, 1 by alpha conjugate lies on second circle. And by solving those two equations, you can try to find value of mod alpha. However, there is another interesting approach of solving this problem using geometrical method. So here if you notice, for these two circles, they have same center. These two are concentric circle. So we are going to plot these two circles, and also for simplicity, I'm drawing the complete circle in first quadrant. However, the actual diagram will be a portion of the circle will be in may not be in first quadrant because center is at 1 plus iota, center is at 1 1, and the radius is 4 unit. Here the radius is 2 unit. But just to explain the idea and to keep the diagram simple, I'm drawing this in first quadrant. So let us say these are the two concentric circle, and this is the center of these two circle at point z naught. Now, before we attempt this problem, there is one important concept that for these two complex numbers, alpha and 1 by alpha conjugate, the argument is same. Right, this is one important point because 1 by alpha conjugate, this you can multiply and divide by alpha, and then it becomes alpha by mod alpha square. And if you multiply a complex number by some positive number, its argument will not change. So this complex number 1 by alpha conjugate is nothing but alpha by mod alpha square, and mod alpha square is always positive. That means these two complex number will always have same argument. That means they will lie on same straight line passing through origin. Now it is given that alpha lies on the first circle. Alpha lies on this smaller circle. For smaller circle, the radius is 2 unit. This is 2 square, and for the bigger circle, the radius is 4 unit. So on first circle, we have the complex number alpha on the inner circle. So let us say this is some point A representing the complex number alpha, and this is another point B representing the complex number 1 by alpha conjugate. And because these two have same argument, they will lie on the same straight line. Let us say argument of each one of those two is theta. So they will lie, I mean, this point O, A, and B, these three will be collinear on a same straight line. And now using simple geometry in one or two line, you can get the answer for this problem. Let us join the center of the circle with origin, and also join the center of the circle with this point B. Let us call this point at some point C, and also join this point C and A. Now, if this angle is theta, we are going to use cosine formula, right? We are going to use cosine formula in two triangles. One triangle OAC and the other triangle OBC. In these two triangles, we'll use cosine formula, and from there, in few lines, we can get mod alpha square. Right, let us say mod alpha is lambda, and also this point was the center of the circle, so this will be 0.11. That means OC, this length is root 2 unit, radius of inner circle is 2 unit, and the radius of outer circle, this is 4 unit, right? So if I write cost, and let us say that modulus of this complex number mod alpha, this is lambda, some modulus of this complex number is lambda, and that means modulus of 1 by alpha conjugate, this will be nothing but 1 by lambda. Now if I write cos theta in this triangle OAC, then this thing is lambda, so we'll get lambda square plus root 2 square and minus 2 square, right? And this divided by, I mean, cos theta is, so sum of the square of two adjacent side minus the opposite side square, and this divided by 2 root 2 lambda. This is cos theta in the triangle OAC, right? In triangle OAC, cos theta will be lambda square plus root 2 square minus 2 square, and that divided by 2 root 2 lambda. And now let us find cos theta in this triangle OBC. So in triangle OBC, the length OB will be modulus of this complex number 1 by alpha conjugate. So that is 1 by lambda square plus this other side, this will be 2 unit, root 2 squares, that is 2. And the opposite side, this is 4. So minus 4 square, and this divided by twice of these two adjacent sides. So that means 2 root 2, and this multiplied by 1 by lambda. So this is the relation that we are getting. And now by solving this equation, one can easily get the value of lambda, and lambda will be nothing but mod alpha. So from these two equations, root 2 you can cancel, right? 2 root 2 you can cancel. So then this becomes lambda square minus 2. And on right hand side, you will get, uh, if I multiply this with, this becomes 2 root 2 lambda. So lambda square we can multiply, and then we have, uh, this will become 2 minus 16. So it is 14. So that means here we'll get 1 minus 14 into lambda square. Right? 2 root 2 will cancel from both sides. And then this right hand side, we'll get 1 lambda and another lambda from here. So we'll have lambda square. So 1 and minus 14 lambda square. So from here you can see that 15 lambda square, this will become 2 plus 1, 3. That means lambda square is 1 by 5. And lambda square is nothing but modulus of alpha square. Right? So lambda square becomes 1 by 5. The question was we need 100 into alpha square. So 100 and alpha square means lambda square, right? Mod alpha square means lambda square. Lambda square was 1 by 5. So this will become 20, right? 100 into 1 by 5. So that should be the correct answer for this problem. So in this problem, basically the important concept is that the argument of these two complex numbers are same. One is alpha, another one is 1 by alpha conjugate. So therefore, if point O, point A and the point B, these three are collinear points. They are on same straight line. Now you have two triangle. One triangle is this triangle OAC. This is one triangle. So find cosine theta in this triangle. And then the other triangle is O, and then you have BC, right? This triangle OBC. Now find cos theta in this triangle, and then by equating those two, we can get the value of lambda square. And once we get lambda square, 100 into alpha square will be 100 into 1 by 5, that is 20. And that is the correct answer for this problem.